Hello everyone, let's talk about solving radical equations. Today we are going to show in this video a bunch of examples showing different radical equations, and we are going to show different situations and how to deal with them. Okay, so we are going to start with this basic one here. We call this one the basic one because the radical is already isolated, so the idea is to simply just, when we get the radical isolated on one side of the equation, we can square both sides and then we can get rid of the radical. Okay, so let's do that. And when we do that, so we are going to start by just writing this equation again, and then I'm going to square both sides. And so this is what it looks like. And then the squaring the square root, we are going to just get the stuff on the inside. So we are going to get 2x minus 3. And then what do we get on the right side? The right side would just be 5 squared, so we get 25. And now it becomes a linear equation. It's really easy to solve, and all we just need to do is to isolate the x. So we are going to add 3 to both sides of the equation. And so we are going to cancel those two, and then we are going to get 2x is equal to 28. Now dividing both sides by 2, because that is the 2 in front of the x, right? So we cancel them, and then we are going to get x equals 14. And so now we get x equals 14, and we should plug it back into the original equation and check if that will satisfy the original equation. So we need to check. And then you may say, why do we need to check? Because sometimes when we plug it back in, it will not satisfy the equation. And so we will need to just make sure that it will work. And so now when we plug it back in, we can check the left side and the right side of the equation. So we can say the left-hand side of the equation, okay? And then it says that is square root of 2 times blank and then minus 3. And the blank, we fill in the 14 there. So we have the 14. So we just put that in, and then we do the calculation. So we get the square root of 2 times 14 is 28 minus 3. And we are going to get what? Square root of 25, which is equal to 5. And you can see that the right-hand side is also equal to 5. And so that's equal to the right-hand side. So this solution works. Okay, let's look at another example. Okay, second example. And we are going to still use the same idea as the first example. We are going to isolate the radical and square both sides, and it just happens that we have the radical isolated already. Then you may say, why do I show another example? It's really because after the squaring, it's a little bit different from the previous example. So we are going to show this and show how it works. Okay, so we are going to do the squaring on both sides again. So we are going to square both sides. Now, when we are squaring both sides, because we have 2 terms over here, we need to make sure that we square the whole thing. Okay, so it's actually wrong. Okay, so let me just write it here. It's actually wrong to say x squared minus 2 squared equals square root of x squared. Okay, so sometimes people will do that, and make sure that you don't do that. And now we got to square the whole quantity of x minus 2. Now, when we square this x minus 2, we actually need to write it as what? We need to write it as x minus 2 times x minus 2. And then you can FOIL this one. But there is, of course, there is actually a faster formula to expand this. And so if we have a minus b squared is equal to what? It's equal to a squared minus 2ab and then plus b squared. Okay, so in this case, a is the x and then b is the 2. So now we can just use this formula to figure out what we have on the left side of the equation. Okay, so we are going to have a squared is x squared, so we get x squared, and then minus because of this minus sign, and then it's 2 times a times b. A and b are x and 2, so 2 times x, we are going to get 4x. Okay, so we get 4x, and then plus b squared. B squared, b is 2, so b squared is 4, so we get the 4 here. So see that that's different from what we have here, because this one is actually just x squared and then minus 4, but that's not correct, right? It should look like this. And then on the right hand side, it's actually simple, so we have just the x over here. Okay, so now the equation becomes a quadratic equation. So all we need to do is to move everything to one side and make the other side 0. So we are going to subtract the x from both sides. So now what do we get? We get x squared, and then we get minus 5x, and then plus 4 is equal to 0. Okay, now solving this equation, we can factor it. Sometimes we're going to use the quadratic formula, but it just happens that this is factorable, so we can actually try to factor. This is x squared, right? So we are going to have 1x, and then we are going to just use the 1x times 1x will give us the x squared. And then the 4, we have two choices. We can have 2 times 2 and 1 times 4. Because we want a 5 here, so we actually will want a 1 and the 4 multiplied together. So 1 times 4, okay? And then it's positive 4, so we need the 1 and the 4 to have the same signs. Now, we're going to multiply them this way. Okay, so you can follow the arrows and then multiply them this way. If we just keep the 1 and 4 as positive 1 and positive 4, we are not going to get negative 5 because we actually need what? We actually need negative 5. And see that 1x times 4 we'll get 4x. And then 1x times 1, we will get 1x. If we add them together, we get positive 5x. To get negative 5x, we actually need both to be negative. So we actually will put the signs over here. Okay, so both are negative, and so that means we need to put the signs over here because 1x times negative 4 will give us negative 4x. Same thing here, so we get negative 1x. And if we combine them together, we add them together, then we are going to get negative 5x. Okay, so that will give us the factorization. And then you may say, how do we write down the factorization? All we need to do is to just read it from here. So 1x minus 1. Okay, so we get 1x minus 1. I will just write x minus 1. And then 1x minus 4. So we just get x minus 4. And that is equal to 0 on the right side of the equation. Okay, so we are getting the solutions. We get x equals, from here we get x equals 1. Or the other one is x equals 4. Now, we cannot just claim that those are the solutions that will satisfy the original equation. We need to check. Okay, so we need to do the checking over here. Actually, let me do the checking over here. So we need to check. So first one, x is equal to 1. Okay, now what happens? Let's look at the equation. The equation is x minus 2 equals square root of x, right? So let's do that. So the left-hand side is equal to x minus 2, right? And then we just plug in the 1 in there. So we are going to plug in the 1. And then what do we get here? We get negative 1. And then the right-hand side, it's square root of x. So square root of, and then we plug in the x, which is 1. Okay, and then now what happens? Then we get positive 1. Are they the same? They're not equal. Okay, so if they're not equal, that means the x equals 1 does not satisfy the original equation. And so that means what? We actually need to cross out this one. This is an extraneous solution, but it doesn't mean that x equals 4 will work. We still need to check it. Okay, so when x is equal to 4. Then now we do the checking. So again, the left-hand side of the equation, we have something minus 2. What is that something? That something is the 4. So we put the 4 over here and then do the calculation. 4 minus 2 is 2. And then the right-hand side is equal to the square root of x, and then x is 4. And then now we can see that it's equal to 2. So those two are equal. So the left-hand side is equal to the right-hand side, and so this would be our solution. So the equation only has this one solution here. The x equals 1 doesn't work, only x equals 4 will work. Okay, so let's do another example. Okay, third example actually has 2 equations, and so it's like the third and the fourth example combined together. Okay, now they're different because we have a square root for this equation on the left side and we have a cube root on the equation on the right side. Okay, so how are they different? let's actually just try to solve them and see what's going on. Okay, so the idea is the same as before. We are going to try to isolate the radical first, okay, and then raise to a power that will cancel the radical. And here, the radical is not isolated because there is a 3 added to it. So we are going to subtract the 3 from both sides first. So we minus the 3, and then we are going to get the square root. So you can see that those two will get canceled. And then we are going to get 4x minus 3 is equal to -1. Now, you may actually say that this would have no solution. Why? Because think about this. If we have a positive square root and that is equal to a negative number, then you can now already just claim that there is no real solution for this equation without actually solving it. But we can actually still just try to solve it and see what's going on, right? So we can actually square both sides. And then once we square it, we are going to just get the stuff on the inside. So we get 4x minus 3 is equal to, now the -1 squared becomes what? +1. And then we can move the 3 over. So we add the 3 to both sides and then cancel those two. We are going to get 4x is equal to 4. So x is equal to 1. Now you may say we are getting a solution, but the problem is that if you plug it back in, it's not going to work. So now let's try. So we can do the checking just like the previous two problems. And so we are going to say that that's when x is equal to 1, right? So we are going to just check that. So now the left hand side is equal to the square root of 4 blank minus 3 and then plus 3. So now let's just plug the 1 in here. So doing the calculation, we are going to get the square root of, well, 4 minus 3 is actually just 1, right? And then plus 3. And then what is 1? Square root of 1? Square root of 1 is 1, plus 3 is 4. But that's not equal to the right-hand side, because the right-hand side is what? The right-hand side is just the 2. So you can see that those two are not equal. And so that means this will not be a working solution for the equation. Okay, now the cube root is actually a different story. We are still going to use the same idea, isolate the radical first. So we are going to get this the cube root of 4x minus 3. And then we actually did the work like before, right? So we are still going to get -1 on this side. But this time we can actually raise both sides to the third power. Okay, then you may say, but we still get a negative number here. Does that mean there is no solution? It's actually possible for the cube root to be a negative number, right? So it's possible that there will be a solution. So let's actually just continue with the calculation. So now the cube root and the cube will cancel each other out. So we are going to get 4x minus 3. And we are going to get -1 to the third power. So multiply -1 3 times. So we are still going to get -1. And then now continue with the calculation. So adding 3, we are going to get 4x is equal to, what is that? That's +2. So now divide both sides by 4. Then we are going to get x is equal to, what is that? That's 1/2. Okay? And then we can do the checking. So when x is equal to 1/2. And so the left-hand side is the cube root of 4 times the blank minus 3 and then plus 3. And so here we actually need to plug in the 1/2 in here. Now let's do the calculation. So we get the cube root of, what is that? That's 4 times 1/2. So we get 2 minus 3 and then plus 3. Then just continue with the calculation. 2 minus 3 is -1. So we are doing the cube root of -1, which will give us -1 plus 3. And so we get +2, which is equal to the right-hand side. So you can see that they are equal. Okay, so that would be our solution. Okay, this time we are going to deal with an equation with 2 radicals, okay? And then you may say, how do we isolate the radicals? Should I just square both sides like this? Or should I just square each one separately? Okay, it actually doesn't work so well. Okay, and actually it's not a good idea to do this because this is not correct. Okay, and then so now what can we do? We are still going to isolate one of the radicals, just isolate one of them. And it doesn't matter which one that you pick, so we just pick one to isolate. Let's say we pick the this one, the square root of 3x plus 4. You can pick either one, it doesn't matter. Okay, so if I pick this one to isolate, then I am going to get the square root of x on the other side. So it becomes 6 minus square root of x. Okay, now this one is isolated and we can start doing the squaring. Okay, and then just like before, we are going to square the whole thing with 2 terms. Okay, not each individual one. Okay, now this one, the square and the square root, they cancel out. So we have 3x plus 4 on the left side of the equation. And then now what about on the right side? The right side actually requires us to do a little bit more work. What happens is that this one, again, we need to write that as what? 6 minus square root of x times 6 minus square root of x. Okay, and we can follow that. But we can still just use that formula as I show in one of the previous examples. We have a minus b squared is equal to a squared minus 2ab and then plus b squared. Okay, so here what happens is that the a is a 6. So a is a 6, and then the b is the what? The square root of x. Okay, so now a squared is 6 squared, so we get 36. And then minus 2ab, so 2 times a and b, so 2 times 6 times square root of x. Okay, 2ab, and then plus b squared plus, okay, b squared, square the square root of x, which will give us just the x because the square and the square root, they cancel out. So now we have this. And then of course we can simplify this middle term. So let me just write it quickly. Okay, so now we still have a square root. And then you may say, what should we do? This time we are going to just do it again. We are going to isolate the square root and then we are going to square both sides again. So generally, if you have 2 square roots in the equation, then what we are going to do, okay, just like this one, we are going to square twice. And each time we need to isolate one of the square roots so that we can do the squaring. Okay, so now the 36 should be moved to the other side and then the x should be moved to the other side. So we are going to subtract 36 from both sides. And then we also need to subtract the x from both sides. And those will get cancelled. So now here we get 3x minus x, we get 2x. 4 minus 36, we get negative 32. And we are going to get just negative 12 square root of x. Okay. Now you may say, should we divide both sides by negative 12? You can do that so that you can isolate the square root of x, right? But then in that case, you have to deal with fractions. It just happens that you actually don't have to get rid of the negative 12 because it's this operation between the negative 12 and the square root is by its multiplication. So in that case, we can actually just square both sides. Here we need to isolate it because we have an addition. Well, actually, let me show you again. So in the original equation, we need to isolate one of the radicals because we have addition here. This one is multiplication. So this one, we do not need to get rid of the negative 12, but here we need to get one of the radicals isolated. Okay, so that is the difference. Now, here, before we square both sides, to avoid dealing with bigger numbers, we can actually reduce the whole equation by 2 because you can see that that's a 2, that's a negative 32, that's a negative 12. So we can divide everything by 2 so that we have smaller numbers. Okay, so those 2 will get canceled. So we're going to get x minus 32 divided by 2, we get 16. And then what do we get here? We get 12 divided by 2, so we get negative 6. So we get square root of x. Okay, so now we are ready to do the squaring because there is no more way to simplify. Also, just one thing to mention here is that when we are doing the squaring, we are going to include the negative sign inside. Okay, so it will turn into positive 36 once we do the squaring. Now here it's actually the same thing as using this formula over here. So this time we are going to just do it without looking at that formula. So we are going to square the first one. Okay, so it becomes like x squared. Okay, and then those two multiply together, so we get negative 16x, and then we get to double it, so it becomes negative 32x. And then plus 16 squared, so we get 256. Okay, and then on the right side of the equation, we are going to get what? The negative sign will disappear, so we are going to get 36, and then what do we get for the x? Just x. I mean, it's really because it's squaring the square root of x, so we just get the x here. Now it becomes a quadratic equation again, so we can isolate, well, actually not isolating, but we can get everything on one side, so we can get 0 on the other side. So we are going to have subtract negative 36 from both sides. So it becomes x squared minus, and then we are going to get 68x plus 256, and that is equal to 0. Okay, and then now we can actually try to factor this equation. Then you may say, should we use the quadratic formula so that we don't need to worry about trying different combinations to make it work? Yes, but they're big numbers, so sometimes it's even more difficult to use the quadratic formula. So actually, maybe factoring is not too bad because the coefficient for x squared is just 1, right? So maybe easy. So let's try it. So we are going to get 1x. I'm just going to try it on the side because that's my scratch word. Now 256 actually has different factors over here, so let's try it. What about... Because you know that for 256, okay, so what really happens is that we can actually just break it as what? We can break it as, because we have 16 and 16, right? So we have 16 times 16, and then we have 4 and 4, then we also have 4 and 4, and it's actually just powers, it's the power of 2. So we are going to just get 2, 2, then 2, 2, and then 2, 2, and then 2, 2. So now there are many different combinations we can do. 1 times 256, obviously that's not going to work because we get negative 68. And then 2 times 128, and then also not going to work. But now because of the 16, and then we also have 4, so 16 and 4 multiply together, we get 64, which is a closer number to 68, and that may be a good choice because 64 times 4 would actually give us 256, but if you add them together, we're going to get negative 68. Okay, so we are going to have 1x times 4, we get 4x. 1x times 64, we get 64x. And we want a negative 68. So that means we need the signs to be in negative in the front. So that means we need the negative signs in front of the negative 60, in front of the 64, and then in front of the 4. And you can see that because both signs are the same, so when we multiply them together, we are still going to get the positive 256. So this is the right combination to use. And so now the factorization, it's x minus 64. And then the other one is x minus 4. So from this equation, we are going to get x equals 64 or x equals 4. Now, we still need to plug that back into the original equation and check just to make sure that they both will work. There is no guarantee that they will work. So now let's do the checking. So check is when the first one is when x is equal to 64. So let's do the checking and see what's going on. The left-hand side is equal to, I don't even remember what the equation is. It's square root of x plus square root of 3x plus 4. Okay, so that is the left-hand side of the equation. So plus 3 times blank and then plus 4, right? And then the right-hand side is the 6. Yeah, so the right-hand side is a 6. Let's just keep that in mind. So we get 64 over here and then 64 over here. Okay. Okay, so now let's do the calculation. So square root of 64 is going to be 8. And then plus. What about this one? This one, let's do the calculation. 3 times 64, so that's 3 times 4 is 12. This one is 12, and then 3 times 6 is 18, plus 1 is 192, plus 4 is 196. Okay, and then 196 is actually a perfect square, so we can take the square root of that, which will give us 14. And that will give us 22. Okay, that is the left-hand side. What about the right-hand side? The right-hand side, of course, is not 22 because it's 6. And so those two are not equal. So x equals 64 is extraneous. Let's try the second one. Is when x is equal to 4. Okay, now the left-hand side. We already have the equation here, so I now don't need to go back and look at the equation again. So we had 3 times blank and then plus 4. So this time we are going to plug in the 4 in there. So what do we get? Square root of 4 is 2 plus 3 times 4 is 12 plus 4 is 16. So square root of 16, which will give us just 4. And that will give us a 6, which is equal to the right-hand side of the equation. So this one will work. And so that means we are having only just one solution for this equation. So the answer is x equals 4. So that's it for this 4 examples, or actually maybe 5 examples. I hope you liked this video. Please subscribe and share this video. Thank you for watching. I will see you next time.